My objective today is to share also my learning process during the last few years, because I've been following the topic of the AI Act, or in general, regulating AI for a while now, and to try to give you a perspective. So the perspective is a perspective of a data scientist. It's a very incomplete perspective, but what can I do in 25 minutes? I will try to include. It's fresh off the press. A few days ago, actually 3 days ago, the EU Council approved the AI Act. So this was the final green light for this new regulation. It's officially a law from now. It's been a discussion which has been going on for years. Probably if you've been following the topic, you heard about regulating AI already for a few years. Right now, we are just waiting for the publication in the EU journal, but it's official. But it's something that started already some time back, before the advent of large language models, maybe when we were still talking a lot about deep learning. They started talking about regulating this kind of systems. There has been a lot of negotiations, a lot of iterations, a lot of modifications in this process. And of course, most important, there has been ChatGPT and large language models. So what was drafted, what was reached as an agreement until 2021 was completely blown apart by the advent of large language models. So the EU itself had to do a lot of running after technology in order to keep up to date with this new, what was happening in the technological world. But the most important part is that what do we define as an AI system? That was also, there was a lot of discussion and negotiation about it, because it's the most important definition. Eventually, the EU decided not to draft a new definition of AI, but to follow what the OECD is saying about AI, so the Organization for the Economic Cooperation and Development. And they decided, okay, from now on, we'll take this definition of an AI system to decide what falls into the new regulation. And this definition defines AI as a system that operates according to a certain objective, and takes some input in a virtual or in a real environment, and transforms this input in an output that could be a prediction or recommendation, an indication on how to follow up on a decision. This definition is very broad. It doesn't cover just machine learning, but covers many more other systems, and it's also a complication. It's something that can be applied, for example, to rule-based systems, for example. But it's a definition that from now on will be used to define what falls into the new regulation. They also had to make a new distinction last year about traditional AI models versus general purpose models. Until last year, they were talking about traditional models, so models that are trained to perform a specific task. So most common machine learning models are trained to solve a very vertical task, like predict the breaking of a machinery, or decide whether an X-ray presents a disease or not. These are defined as traditional AI models, and certain rules applies to these models, but they had to introduce a new definition of general purpose AI, which are models based on a concept of pre-training, and models that are used on a more broader scope. So for example, AI assistants. They created GPT on a pre-trained, with a pre-trained approach. They didn't have a specific task in mind. People are using ChatGPT for different reasons, to help with coding or to help with summarization. There's no specific task, and this defines a new family of systems, this general purpose. So there's this big distinction. Today, we'll talk about category 1 mainly, because it's also the one which is more regulated. And the most important aspect that the AI Act introduced is this pyramid of risk definitions. So they decided, okay, we defined what's an AI system. We defined also where these systems operate. There can be different categories where the system can operate according to certain risk levels. So they defined initially 4 levels of risk. And then they added this lower step of the pyramid after ChatGPT, based on how what is the risk associated with undesired behavior with this machine in the kind of system, in the kind of context. So first of all, they define some categories that are defined as unacceptable risk. So from now on, these categories are not allowed in the AI world. We decided that there are some conditions where AI systems shouldn't be operating. They defined these high-risk systems, where are systems that operate in conditions where a wrong output of an AI system can have bad consequences on people's life, basically. And then they defined systems associated with lower risk that require less attention. And at the bottom, they also created a separate category, as I was talking before, about general purpose AI. So a different kind of attention dedicated to this system. I'm talking about regulation, but I forgot to say that this is, first I said the first comprehensive regulation, because this is the first time we are trying to have a comprehensive approach to this problem. That doesn't mean that regulation doesn't exist. There is already some regulation in place about AI. For example, the GDPR states that you can do or you cannot do something when AI systems interact with people's life. In other countries, there are some very vertical or very specific regulation about AI. For example, in the state of New York, they are adopting some constraints or some limitations on what AI system cannot and can do. But this kind of risk-based definition, this kind of approach is the first time we are trying to tackle the problem in a very comprehensive way. So what happens, first of all, what happens with prohibited systems, with this unacceptable risk? From now on, we cannot use these systems anymore. The EU decided that there are some categories, some working conditions that are not acceptable anymore for AI systems. And these are categories such as social scoring. We cannot use AI to give a score to citizens in Europe. We cannot use AI to categorize citizens based on biometry. We cannot use AI working on facial recognition databases. This is not straightforward. Like in other places in the world, these applications are allowed. So from now on, in Europe, this won't be allowed. So from now on, I mean, from 6 months from now, this application will be forbidden. So we cannot even think about using it. And the most complicated part comes with high-risk systems. So systems that are working in conditions where bad choices or bad predictions for the models can have severe consequences on peoples and on infrastructure. So this new regulation defined some categories that will fall into this on this step of the pyramid, categories such as systems working with critical infrastructure, so with transportation or energy, system working in training or education, or system working in safety in general. So whenever there is the risk of having severe consequences on some AI misbehavior, this is categorized as a high-risk system. And this, in the regulation, is the most complex part, because the new regulation defines a lot of requirements that this kind of AI systems need to fulfill in order to be used in the EU from now on. And they defined a list of requirements. These are technical requirements of these systems that will need to be demonstrated in what's called a conformity assessment. So we have some technical requirements. From now on, companies working with high-risk systems will have to create this conformity assessment, which is an evaluation process that will demonstrate that these systems fulfill all these requirements. And these requirements are very broad. They are requirements about how we are documenting our system, how we're writing technical documentation. There are requirements about how we prepared and curated the data, how we defined, how we divided the data into training, validation, and test. Requirements about how also we deal with risk associated with the systems, because in any risk-based approach, we cannot simply assume that the risk is zero. We have to estimate what is the risk of something bad happening, and also to define what is the strategy of our response to these events. So it's very technical. For example, they talk about robustness, accuracy, and cybersecurity. These are very technical terms. If we talk about robustness, it's a term which is grounded mathematically. We have a mathematical definition of what a robust system is. Unfortunately, until now, the definition in the regulation is very high level. There is no technical definition of what do we mean with an accurate or a robust system. The intention is in the next coming 1 or 2 years to also to come up with a standardization. So we have a requirement, how do we fulfill this requirement? And this might vary a lot depending on the vertical we are operating. So a system working in the medical field might have different requirements than a system working in the educational field. The problem is that creating this kind of conformity assessments is a process that involves different stakeholders. So there might be people working on the model, data scientists or data engineers. There might be project managers. So some people asking for a business need to be solved, understanding what is, for example, also the consequence of a bad decision of a system. So it's a situation where we have different people interacting with each other with different expertise and with different expectations about an AI system. And the question, in my opinion, the most interesting question was that what is going to be the role of a data scientist in this context? And it's very difficult to give an answer in the next 10 minutes, but I recommend reading this paper, which was authored by Professor Floridi from, back then he was at the University of Oxford, but now he's in Yale. And it's a procedure to perform conformity assessments. It's still a bit high level, but it's the first time I managed to read something that was also referencing some technical solutions about how to fulfill these requirements. And in this paper, for me, it's quite interesting because they do mention what are the different stakeholders in an AI system, and they do mention what are the responsibilities of a data scientist among the other stakeholders. And in this paper, they say that the data scientists are responsible for documenting how the system, the AI model is performing with respect to the training and the testing environment, so the training and the testing data. They have to justify what was the process leading to the final design of the system. So what was the based on deciding what are the best hyperparameters, for example, if you are using a machine learning model that have been chosen and define the system as is. And most of all, they have to identify what are the breaking points of the system, because remember, we are talking about risk analysis. We have to define what can go wrong in our system, and when we define what can go wrong, somebody else, for example, another stakeholder, a risk expert, might decide what can we do when things go wrong. But the role of a data scientist is to find what are the failure patterns of a model. And it's not an easy task, and in my opinion, I would argue that this boils down to a problem that many data scientists know about machine learning, which is the black box issue. So as systems become more and more complex, understanding how do they behave is becoming more and more challenging. It's often called the black box problem because we might have a system like a neural network that gives very accurate answers and without giving the user or even the developer an answer about how they came up with this decision. And in a context of risk analysis, this is a problem because we want to understand how the machine operates and what are possible failure points, and what are possible situations when the machine is not good to operate. In literature, there are a lot of references on how to do what we call a model assessment or model auditing. So we do train a machine learning model, we do analyze this model from a global point of view, but we also want to understand what are the local characteristics of this model. There is a lot of literature and a lot of methodologies also coming from academia. Of course, we are at a Python conference, so I think I'm contractually obliged to talk about Python in this talk. There's a lot of libraries and a lot of interesting material. Today I decided to talk about a library. It's called DeepChecks. I don't know if you've ever heard about it. I'm not affiliated in any way with this library. It's an open source library. I think it's quite interesting because it creates some kind of boilerplate for what does it mean to validate and to analyze a model. It's open source. It can be applied to different kind of models and data sets, from tabular to image to text. And on the long term, I don't think people should use this library to do conformity assessments, but for me it's educational because it's based on a very automated, it has a very automated focus. So the idea is to create this kind of validation test as automatically as possible. And this kind of automated process also can give a lot of ideas about what could be interesting tests. Even if you want to learn about how to do model validation, I think it's a good way to check what this library is doing and maybe take some inspiration. And I wanted to show you some practical example from a notebook. I picked a toy dataset, a toy problem. A dataset from the Lending Club dataset. Maybe you heard about it. It's a dataset where a model should be trained to predict the risk of lending money to a certain individual. It's a binary classification task. So we have a target column called default, which tells if this individual after a certain point of time was not able to repay the loan. And the model should make a decision based on characteristics of the application for this loan. For example, they might ask for a certain amount of money. They might ask for a different time spent to repay the loan. They might have a different income. So it's a fairly simple toy dataset. Let's say it's quite interesting because it's already a dataset containing numerical columns rather than categorical columns. And whenever we are working with tabular data, right now, the model to go is a model based on gradient boosting. In this case, in this example, I'm using cat boost, which is a model based on boosted risk, which has a very nice advantage of dealing internally with categorical columns. So whenever there is a categorical label, as long as I provide the model with information about this categorical label, the model knows how to tackle this aspect. This is just a toy problem, so it's not nothing really tuned or nothing particularly not a super performing model. It's just a reference to show you these tip checks. But after fitting the model, we might want to test it on a test data set and see some kind of global metric. So we see that it's a binary classification where the default label luckily is much rarer than people being able to repay the loan. It's a model which is going okay. There's a decent precision and a fairly low recall. I didn't do much to improve this model. The idea here is to show you how can we go deeper into analyzing this model. So usually what we do, we might look at the feature importance, how much importance the model is giving to every single feature, and that's quite easy because we are using a boosted tree approach, and that's some information we already have inherently with the model. But the most interesting part, and I will just skip to deep checks, is to use this library, which is a library that tries to automate what are the most important checks that we need to apply to a model to validate it. And to import it, we just have to create this dataset class that takes a pandas data frame as an input. We can specify which is the target column and what are the categorical columns, so the columns that are associated with a categorical label. This tool can do a dataset analysis, and I won't go through it now because of time. The most interesting part is that it can do a model evaluation. So provided that we define what is the trained dataset and the test dataset, we can feed a classifier. It accepts any kind of scikit-learn-based API or XGBoost or CatBoost. And it automatically generates a report containing a lot of different tests. And this report can be saved in an HTML file. And it's a report that contains a lot of different tests that have been applied to the model. Most of these tests will pass. Some of these tests won't pass. And I wanted to show you an example of a test that didn't pass because I found it particularly interesting. So here it performs a test called weak segment analysis. And what it does, it automatically divides the data set in data segments, trying to understand where the model is more likely to fail. So internally, they have a library to take the data set, define some intervals for numerical columns or groups of categories for categorical columns, and it automatically divides the data in these segments, understanding whether there are some portions of the data where the model is going better or worse. So in this case, one of the tests that didn't pass is the fact that the model might have a global accuracy, which is decent, but then if you try to break the data set in different segments, you notice that for some kind of data points, the model will work much better, and for other kinds of data points, the model will work much worse. And this is very interesting because this kind of analysis, for example, tell us that for people who applied for long 60 months, the model is doing much worse than for people who applied for 36 months loan. And that's a very useful information because we might understand that the model is not designed to work properly in this kind of interval. So, for example, for low-income people with loans for after longer than a certain length. And this information is something that a data scientist can collect and package and provide to somebody who will then make a decision about what to do with this information. So they might say, okay, I won't use the model for this kind of population, or I will do something else to mitigate the risk of the model not working very well for this population. This analysis is also very interesting in terms of bias and fairness. I won't have time to talk about it today, but we could do the same analysis for, instead of talking about categorical features in general, about population segments in terms of protected categories. So we might understand that the model is working worse for females rather than males, or younger people rather than other people, and that's a very precious information. And this is a very short example. I would recommend to have a look at the library just because it gives a nice introduction. I just wanted to conclude because there's a lot of talking about whether this kind of regulation is useful or not in terms of competitivity of Europe compared to other continents. They say that having too much regulation might slow down progress in AI. I would say that this kind of conformity assessments, at least, is quite important because it's something that all data scientists should do. It's something that has a lot of value, especially considering what are the statistics in terms of machine learning. They say that among a lot of R&D and a lot of projects are being organized and funded to investigate how to use AI, but only a small portion of them actually become tools that are used in production, that are used in real life. And one case particularly important is in medicine. There's a concept of translational medicine where we want to transform what we do as research in academia into something which is really used in real life. And recently, there's a lot of talking about the fact that the great majority of research in AI medicine doesn't even reach clinical studies. And there are a lot of papers that started studying this phenomenon. For example, papers that have analyzed all the papers that have been published during COVID about creating the best model to detect lung COVID diseases based on radiographies. And these papers are always fundamentally flawed. They always have problems such as data leakage, lack of interpretability, lack of understanding how the data was prepared and curated, which made the models and the research effectively useless. So in this case, doing this kind of conformity assessment would have been something that could have transformed something which was pure research in something that had much more potential to become something useful. Concluding, will the AI Act is now law. By 6 months from now, prohibited system won't be allowed anymore. High-risk system will be regulated 3 years from now. So we have this kind of buffer time to understand also technically what does it mean to do conformity assessments from a technical point of view. But they're going to be interesting times because it is a law, but we still have to define all the details and all the important aspects about what does it mean to understand AI systems in this kind of context. And I will conclude within 25 minutes. So, okay.
Perfect.
Thank you.
Thank you very much, Luca. We have a few questions. First of all, one thing that you just mentioned about the deadline. What about the fines? In particular, what are the fines or penalties in case you don't fulfill the AI Act requirements? And if you have I read something, I'll let you.
I don't remember the numbers, but it's like the GDPR. So it's a percentage of, it's either the maximum between the percentage of the revenue of a company and a certain amount. And it varies according whether you're using a prohibited system or misusing a high-risk system, but I don't remember the numbers there.
Yeah, I can say for the ones I'm quite vital, they go to millions. For high risk, it's way less. Yeah, thank you. Yeah. What happens, so in particular this is connected, so what happens if the users of the system, not their development, if they don't comply? I guess is a similar questions. I don't know if you want to add something in this reframe of the question.
Maybe an interesting detail that I forgot to mention is that for high-risk system, all these conformity assessments are self-assessment. So for most of them, there are some systems where there should be some notified body checking on these assessments, but most of them will be self-assessment. So it's like basically like GDPR. You might, like as for data, you need to do like a data privacy impact assessment, and then there might be some inspection. With AI Act, you will have to prepare this kind of reports, and then eventually you might get checked and pay the consequences of not doing it if you're busted.
We hope people will enough education to be able to self-assess, but this will be a great start. And do you know if for the AI CV screening model, they will fall in the high-risk system regardless their complexity?
Yes, I think so. It's because if they're simpler models, then it will be much easier to demonstrate that there are very low risks associated with the model. If you have like a rule-based system, then it's straightforward to do a conformity assessment. But HR is really one of the categories where it will be mandatory to these self-assessments.
I read the question directly. What about transparency risks for LLM? You mentioned them in the pyramid, but I would be interested to know more about the data scientist perspective of them. So you, in this case.
Yeah, it's well. First of all, going back in time, they included this category of the chatbots before ChatGPT. They thought chatbots were very harmless systems where the only requirement was to specify somewhere that the user was interacting with an AI system. That's still the case for most of general-purpose AI models. So depending on the context, like they created this separate category for a GPI, and depending on how they are used, because even language models can be used in different contexts, and different contexts will have different risks associated with them. But for if you are operating with a large language model in a high-risk setting, you will have also to demonstrate some not the same requirements of the that I showed before, but another set of requirements such as robustness to adversarial attacks, robustness to poisoning, and so there is another list that I didn't mention today. But
yes, thank you. There is a question in particular for the deep check, sorry, fairness and deep check deals somehow with infrequent classes, and in particular. If not, it would be interesting returning an output, like not enough data points to assess fairness. And also some compliments for your talks, if you can expand more on fairness, if you mind.
I think deep checks might have the limitation that when you have a system which is automated, you lose in freedom of using it in a customized way. It can handle, for example, when dealing with labels, either in the input or in the output. In the input, it has an automated way of handling. It groups all the rare labels in a single other category. And for outputs, you can specify your own custom metrics to measure this kind of specific metrics. And for fairness, I mean, DeepChecks is not really the library to go to measure fairness. I think it's my idea is that this kind of segment analysis is the way to go, because it's already what other tools that are completely dedicated to fairness are doing, like Equitas or Fairness 360. They divide the data in protected segments, like depending on the context. Like if you're in a medical domain, you might be interested in checking what is the model doing with respect to different age ranges, or and they analyze that the model is performing equally in these segments. So you might be interested in a model that doesn't make more mistakes for a gender rather than the other, for example. But this kind of segmentation is maybe DeepChecks is not the best way to do fairness analysis, but fairness analysis is usually based on segmentation.
Yeah. Thank you, and thank you also for mentioning the other libraries on fairness as well. There was one question, a quick question. DeepCheck could work also. We mentioned LLM, but in general, could work with deep learning also more in general, right?
Yeah, yeah. I never used it for images, but yeah, I saw that there is a module for images as well.
There was a peculiar question about, do you think, in your opinion, that this regulation could be more an opportunity for lawyers and data science, or due to the importance of governments, is a matter of fact? Yeah, I'll let you reply to that.
Yeah, yeah, no, it's an interesting question. It's, I think it's, I mean, there's a strong analogy with GDPR, right? Sometimes GDPR can be perceived as a pain because we have to put a lot of layers on what we cannot do with data. We have a lot of DPOs always shouting at us about how not to use the data. But at the end of the day, it's also useful for us as citizens, because it's a way of protecting our rights, and I think we benefited from GDPR compared to other countries. My feeling is that it will be the same for the AI Act.
Thank you. Yeah, in this age, we saw a lot of regulation that came to be quite spread from China to US to EU finally. So EU probably is the stronger and more stable for now. And something that could be very interesting to hear your opinion about regarding this regulation. Which is the best way to leverage and gain value from synthetic data?
Yeah, that's a very good question.
To address.
No, first of all, the AI Act talks about regulatory sandboxes, so the platforms where organizations can experiment with models and with AI systems, and they explicitly mention synthetic data in this kind of situation, like to create this kind of test beds for models. And in our experience, also in our startup experience, once you identify a bias with a data set, a bias with a data set that propagates to the model, synthetic data can be really useful in mitigating this bias. So once you identify the problem, to inject your own expertise or your own requirements about how the data should look, and therefore the model.
Thank you very much. Can you show again where we can get in touch, just in for further, which one do you think is best? Email?
Yeah, email
probably.
Usually, yes.
Yeah, okay. So for the question, yeah, very last quick questions.
When speaking about prohibition, what exactly is going to be prohibited? How do we identify the models?
There's a very detailed article about what are prohibited systems. Basically, you can find a checklist that will tell you whether the system is okay or not. But usually, I think this covers 90% of the categories mentioned. So if
do you mind to talk together after this? We have the time that we have for now. So thank you very much, Luca, and
thank you.